Okay. Can you please tell me about yourself?
Yeah, sure. So I am a backend Java developer with around 3.2 years of experience, and I have experience in designing and developing enterprise level applications using Java, Spring Boot, microservices. So in my current project, I have been working in the anti-money laundering domain, and there our application helps European banks with transaction screening and risk management. So we integrate the third-party screening engines such as Lexnis and Dow Jones to detect the suspicious transactions in real time. So my responsibilities include developing and optimizing RESTful microservices and implementing Spring Data JPA for database interactions. And apart from that, I also ensure the performance and reliability through asynchronous processing, caching, and circuit breaker patterns. And I have primarily worked with Java 8 and Java 11, and my main focus is mostly on writing the clean, maintainable, and efficient codes. And I also use in Java 8 like streams, Lambda, functional programming, and all. So I also do the code reviews, production issue analysis, and deployment automation using the tools like Maven, Git, and Jenkins. So yeah, so these are what are all about myself and my project.
Okay, so can you explain how your transaction screening process works?
Yeah, sure. So in our project, we build and maintain a transaction screening application. So that is basically being used by the banks. So let me quickly, let you know the whole process. So whenever a financial transaction happens, so for example, a fund transfer or payment, that transactions data first comes into our screening service. So which is one of the microservices developed by Spring Boot. So this service takes the transaction details such as sender, receiver, amount, country code, and all. Then this information we send to third party screening engine. So these providers have the global watch list that contains the name of the sanctions, like whatever the individuals which has been sanctioned, or any politically exposed person or high risk entities, whatever it is there. So from there, it will be filtered out. So it goes there. Then our service integrates with these engines through the REST APIs. So we send the data as a request and receive a screening response. So which contains a risk score, match details, or sometimes no match if the transaction is clean. So once we get the response, we process it internally, and if the positive match, if it is positive match, the transaction is flagged as, and that the transaction is flagged and pushed to a review queue where compliance officers manually verify it. But if it's false positive or no match, the transactions moves forward automatically for further processing. So from a backend perspective, we handle all this using Spring Boot microservices communication via REST, and we persist results using the Spring Data JPA with PostgreSQL. Then we also maintain an audit trail for every screening event for regulatory compliance. And to ensure the performance, we use asynchronous call and thread pools because sometimes the third party API response can take longer. So we have also implemented caching for frequently accessed reference data to reduce latency. Finally, we have monitoring and alerting in place. So if any of the third party APIs fail or time out, our circuit breaker triggers fallback logic, and the transactions is retired or marked for manual review. So, in summary, we can say our transaction screening flows start from the receiving transaction data, integrates with the external AML providers, and processes the result internally and ensures the auditability and resilience throughout the process. Yeah.
Okay, so can you tell me how do you handle the large volume of financial data?
Yeah, for to handle that large volume of data, we have implemented several strategies, like both at application and database level. So from the application side, our entire system is built using the Spring Boot microservices, and database level, we are using Spring Data JPA with PostgreSQL. So basically, this Spring Boot and microservices, I mean Spring Boot with microservices that allows us to scale data horizontally. So each microservices handles a specific responsibility. So for example, screening, audit, logging, or reporting. So all these are we have developed a separate module for all these. So wherever we need to have, like, we want any module to work more, we can have like more instances of that, and it will handle the more traffic. And in case of whenever suppose there are very high volume of transaction comes at once, so we use messaging queues, Kafka or RabbitMQ to process transactions in a decoupled and non-blocking way. So producer in this case produces, but consumer don't need to consume at this very same time. So they can consume whenever, as per their convenience, they can consume. So this ensures that even if the downstream services are slow or temporarily unavailable, we can still accept the new request and process them later. Then coming to again on the database side, as I told, we are using Spring Data JPA with PostgreSQL. So we have optimized performance through the proper indexing, pagination, and batch insert update instead of single record operation. So for reporting or analytical use cases, we also use read replicas to reduce load on the main databases. And we are also using caching and to ensure the stability. We have monitoring and alerting set up via Prometheus and Grafana, so we can keep an eye on performance metrics like throughput, latency, and error rates. So yeah, so these are the basically steps we have taken in order to handle the large volume of data.
Okay, fine. So can you tell me the difference between Java 8 and Java 11?
Yeah, Java 8 was one of the most, we can say, revolutionary release in Java history. So it introduced several modern programming features such as Lambda expression, stream API, functional interfaces, optional classes, datetime APIs, and all. So that basically brought a functional programming style to Java and made the code more concise and readable. And it also introduced default and static methods in interfaces, so that basically allows developers to evolve APIs without breaking existing implementations. And then coming to Java 11, so that is long-term support version that built upon the improvement made after Java 8. So it introduced the HTTP client API, making it easier to perform HTTP request in a modern and asynchronous way. And then it also added several new string utility methods like, I think, is blank, lines, repeat, strip. So all these methods were added in this Java 11. And then additionally, Java 11 removed deprecated modules such as Java Enterprise Edition that streamlined the JDK and made it lighter. And it also brought improvement in the garbage collector local variable syntax, like var in Lambda expression, and better container awareness for cloud deployments. So basically, in short, we can say like Java 8 had more focused on introducing functional programming capabilities, while Java 11 focused on the like more modernization, simplifying, and optimizing the platform for better performance and cloud readiness. So yeah.
Okay, can you explain how Lambda expression works internally?
Internally, so basically, Lambda expressions in Java 8 are implemented using the mechanism called invoke invoke dynamic. So that was basically introduced in Java 7 as part of the JVM instruction set. So when we write a lambda expression, for example, let's say we have runnable, right? So runnable are equal to let's say any method declaration, what the definition we are writing. Okay, so in that case, that compiler does not create a separate dot class file like it used to do for anonymous class earlier. So instead, it generates a lambda meta factory and that call using the like invoked dynamic, so which dynamically creates an instance of the functional interface at runtime. So this approach gives several advantages, basically better performance and memory efficiency since no additional class are created, which used to happen in case of anonymous class. And also lambdas are like lightweight and multiple lambdas can share the same implementation method reference. So yeah, so that is how like internally it works. So from JVM's perspective, a lambda expression is essentially the like synthetic
Okay, fine,
for
fine. Okay, so can a lambda expression throw checked exceptions?
yeah, a lambda expression can throw a checked exception. So that can only throw checked exception only if the functional interface is like only if the functional interface it implements allows them, then only it can throw. So for example, we have to explicitly say like in the body throw new like whatever input output exception. If we explicitly we are saying that inside the method, uh, then it will throw. But suppose if we are not doing that, so then in that case it won't throw that exception. So basically like a lambda expression in Java does not have its own exception handling signature. Its exception behavior is governed by the functional interface type it's assigned to. So yeah.
Okay, so can you tell me if the streams are lazy or eager?
Yeah, streams are lazy actually. Yeah.
Okay, can you explain more?
Yeah, so let's say we have a list dot stream and uh, let's say for example let's say list dot stream dot filter we are doing, and then like we are doing map and then to list, let's say this kind of operation we are doing and we are applying on a stream, then only the terminal operation to list actually triggers the whole execution. If we don't apply to list, then actually it won't execute the whole, I mean this filter and map everything. So the intermediate operations are not performed one by one over the entire collection. So they are fused and processed element by element on demand. So as soon as we apply the terminal operation to a list, then only it will be running. Yeah, it will be executed.
Okay, do you know the peak method in streams?
Yeah, peak method in an that is intermediate operation in the Java Stream API that allows us to look at the peak into the element of the stream as they pass through without modifying them. So basically peak we use for like kind of for debugging purpose. So in the middle of the operation, whatever stream we are doing, and we want to know what is the current value, like let's say we are applying the filter operation, so we want to just like see each element how it is flowing and what is before filtering, what is out after filtering. So that's the purpose of peak basically. So we can just print the whole data like one by one before and after any specific operation we are doing. So yeah.
Okay. Okay. So what happens when you put a key in a hash map that already exists?
Yeah, if we put a key in a hash map that already exists in the hash map, then it will replace the old value associated with that key with the new value we are inserting, because keys in the hash map that is must be unique, right? So that is how it will behave.
Okay, so what happens if the keys are different objects but have the same hash code?
Uh, Keys are different objects but have the same hash code. Okay, so if two keys have the same hash code but are not equal, I mean using dot equals, then they go into the same bucket. Hash collision happens. So the hash map stores both entries in a linked list or tree, we can say, from the like Java 8 onwards. So that is the within that bucket. So when retrieving, Java checks equals to find the correct key. So
And what about the nulls? What happens if you insert null key or null value?
yeah, actually Hashmap allows one null key and multiple null values. So the null key is always stored in bucket 0 also. So yeah, so that is possible. So one null key can be done and null values can be many.
Okay, so one more thing, what happens if two threads modify a hash map at the same time? So, what will happen in this case?
Yeah, so Hashmap is not thread safe. So concurrent modification can lead to data inconsistency or even the infinite loops. So we can use concurrent Hashmap in this case in multi-threaded environments. So yeah.
Okay, so why does a multi threaded app show inconsistent values even if the fields are private?
Yeah, even if the fields are declared as private, then it can still be accessed by multiple threads through shared object reference. So the private keyword only controls accessibility, not thread safety or memory visibility between the threads. So when multiple threads modify or read the same variable without proper synchronization, then multiple problems can happen, like race condition can occur. So one thread may overwrite another update, and also visible issues can arise. So one thread might see the value rather than the latest one written by another thread, and also the reordering by the compiler or CPU can cause operations to execute out of order, leading to inconsistent state. So to ensure the thread safety, we must explicitly enforce visibility and atomicity. So for that, we can use synchronized keyword, volatile, or atomic. So these things we can, and also as I told earlier, like concurrent hash map, concurrent, and copy on right array list. So all these things we can use. So in case of multi-threaded environment. So yeah.
So, what is the race condition?
Yeah, race condition occurs when multiple threads access and modify shared data concurrently, and then the final result depends on the like timing of the execution. So that is what is the race condition. So basically, let's say suppose for example, two threads incrementing a counter without synchronizing um, may both read the same value and overwrite like each other's update.
Okay, so what is the difference between synchronized method and synchronized block?
Yeah, synchronized method basically locks on the current instance, like the this we write, right? So it locks on that, and synchronized block lets us the like to choose the lock object. So basically, synchronized block is more flexible.
Okay, what will happen if we write system.exit in the try block?
Yeah, then JVM terminates immediately if we write system.exit.
And what about the finally block? Will it be executed?
No, finally block also will not be executed. So then and there itself the uh, program will be terminated.
Okay, what are the scenarios when finally does not execute?
Yeah, one is this, as I told, like system.exit, and then Also, if suppose because of any issue, JVM itself crashes. So in that case also like finally won't execute. So if suppose if out of memory error and all it comes, so that is also one thing. And then the thread executing the try finally is killed, suppose. So if another thread calls thread.stop on the current thread before the finally executes, so in that case also it may never run. And then also there might be one scenario that if the try block never completes, for example if the loop forever or blocks indefinitely, like because of some while loop or something, so in that case also the chances are there that finally will not execute actually. So yeah, so these are the scenarios are there. Yeah.
Okay, can you override a static method in Java?
No, static method belongs to the class, not to the object. So we cannot override the static method in Java. So if a subclass defines a static method with the same signature, so it's basically method hiding, not overriding.
So can a constructor be final, static, or abstract?
No, constructor in Java cannot be declared like final. So the final keyword prevents a method from being overridden in a subclass. But constructors are never inherited or overridden, so they are called explicitly when creating an object. So declaring the constructor final is like kind of no meaning. And then the static is also not allowed, because a constructor purpose of the constructor is to initialize an instance of a class. The static keyword belongs to the class basically, not the instance. So the since the constructor are tied to the object creation, so it makes again no sense to mark them as static. And then coming to like abstract constructor, so abstract means the method must be implemented by a subclass, but constructor cannot be inherited or overridden. So a subclass cannot provide an implementation for a abstract constructor. So yeah, so it is not allowed. Yes.
Okay, so can you override a private method?
No, we cannot override a private method in Java because private methods are not visible to subclasses. The subclass cannot access or inherit them. So if a subclass defines a method with the same name and parameters, so it's treated as a new like method, not override. So we cannot. Yeah.
Okay, so what is the difference between double equal to and dot equals?
Yeah, double equal to compares references, basically memory addresses for objects, while dot equals compares the contents or values of objects. So, for example, two different string objects with the same text will return false with double equal to, but it will return true if we say dot equals. And for primitives, double equal to compares actual values. For objects, it checks if they refer to the same instance unless dot equals is overridden.
Okay, fine. And what is the difference between string builder and string buffer?
Yeah, both are mutable classes used to build and modify strings, but string buffer is thread safe because its methods are synchronized, while string builder is faster and not synchronized. So it makes it suitable for single thread environments. So functionally they behave the same, but string builder is preferred unless thread safety is needed. So yeah.
Okay, and what is transient keyword?
Yeah, transient keyword prevents a field from being serialized when an object is converted into a byte stream. So it's used to mark fields that are sensitive or like derived. For example, we have password and all, and that should not be persisted when the object is written to a field or transmitted over a network. So yeah, so under those fields we put a transient keyword.
Okay, what will happen if you use null keys in concurrent Hashmap?
Null key in concurrent. In concurrent Hashmap we cannot put null keys or values. So it will throw null pointer exception. So null keys values are not allowed in concurrent Hashmap. Yeah.
Okay, and can you tell me why these null keys and values are not allowed in concurrent Hashmap?
Yeah, it does not allow null keys or values because it would break the thread safety guarantees and create ambiguity during the concurrent access. So ambiguity will happen because in a regular hash map, if we call map.get key and get null, it could mean either the key does not exist or the key exists but the value is null. So in a multi-thread environment, this ambiguity becomes very dangerous. So we cannot tell like whether the key is missing or another thread removed or they updated it. So concurrent hash map eliminates this confusion by forbidding the null values. So that is the main reason. And also we have like thread safety and atomic operations. In that case, concurrent hash map supports atomic operations we have like put if absent and all, right? So if we allow null in this case, so that will also again make it unclear whether the mapping is absent or just like it holds a null. So again it makes it impossible to guarantee atomic consistency across the threads. So yeah, so that those are the reasons are there. Yeah.
Okay, so what is Spring Boot and why do we use it?
Yeah, Spring Boot is a framework built on top of the Spring ecosystem that simplifies Java application development by removing the need for complex XML configurations and all. So it provides auto configuration, starter dependencies, and embedded servers like Tomcat, which allows us to quickly build and run production ready applications with minimal setup. So the main goal of the Spring Boot is to make the development faster and deployment easier by following the uh, convention over the configuration principle. So that's what is the Spring Boot. Yeah.
Okay, and what are Spring Boot starters?
Spring Boot starters are a set of predefined dependency descriptors that simplify adding dependencies to the project. So, for example, if we include Spring Boot Starter Web, it automatically pulls in all the required libraries like Spring MVC, Jackson, and embedded Tomcat server. So this avoids manual dependency management and it also ensures the compatibility between the versions. So we don't have to like worry about the like version dependency between the jars and all. So developer can only focus on the logic rather than the configuration. So yeah.
Okay, so can you explain in very short, like how do you create a REST API using Spring Boot?
Yeah, to create REST API in Spring Boot, we can use at the rate of REST controller. Like basically, we will be having the controller service class, and then we will have the repository. So in the controller, we can have this annotation at data REST controller annotation along with mapping annotations like we can have get mapping, post mapping, put mapping, and all, and delete mapping. So for the CRUD operations, so the controller handles HTTP request and responses, and we typically return JSON objects, which Spring Boot handles automatically using the Jackson. So for example, if we define a class with a REST controller and map an endpoint like let's say forward slash API users and return a list of users, so Spring Boot takes care of the serialization and the response handling. So that is how we can create the REST API. Yeah.
Okay, so how do you handle exceptions in Spring Boot?
Yeah, exceptions handling in Spring Boot is usually done using the like add controller advice and add exception handler annotation. So we can create a global exception handler class annotated with add controller advice, and inside it we can define the method that handle the specific exception or return custom error responses. So Spring Boot also provides a default error response structure via its basic error controller. So that can be customized using an error controller or like error attributes. So that is how we can handle actually the exception.
And what is actuator in Spring Boot?
Yeah, in Spring Boot, Actuator provides production ready features that helps monitoring and managing the application. And by adding the Spring Boot starter actuator, we can add dependency in the pom.xml in case of Maven suppose. So we get several built-in endpoints like actuator health, matrix, like environment. So that exposes the useful information about the application's state, performance, and configuration. So it's widely used for the application health checks, especially in microservices deployed on Kubernetes or cloud environments. So yeah.
Okay, so let's say suppose if our application is taking too long time to start Spring Boot application. So how do you diagnose this and how will you optimize it?
Yeah, so if a Spring Boot application takes too long time to start, then the first step is to analyze the startup logs by running the application with, we can say, minus minus debug. So that is a flag. Or also we can like enable like some Spring framework able to debug, that also we can do to identify which beans are taking the most time to initialize. So mostly like slow startup is caused by sometimes heavy post construct logics or database connection, or I mean it can be anything. So we can review those carefully, and we can enable lazy initialization using like Spring lazy initialization equal to true. So that helps defer the bean creation until they are actually needed. So that basically improves the startup time. And then I will also use Spring Boot actuator application startup matrix to trace the initialization phase. And additionally, we can check for unnecessary dependencies, auto configuration, or component scans that load too many classes. So in some cases, profiles took tools like Visual VM or like there are other tools also. So they are also helpful to identify the classes loading or initializing bottlenecks. So yeah, so these are the steps I will take, and it can also be database as well. So um, database connection might be taking some time, or by default it might be executing some queries or something. So that also we need to check. So yeah, so these are the things we can do. Yeah.
Okay, so coming to microservices, what are the challenges you think microservices has?
Yeah, key challenges can be like distributed system complexity, data consistency, inter-service communication, and the monitoring of the system. So these can be the key challenges. So debugging and tracing issues across multiple services is kind of not easy. It is kind of hard, and managing deployments, network latency, and versioning can be complex. So these are the challenges basically, and also it requires a strong DevOps practices and like observability tools like centralized logging and tracing system. So these are the challenges are there. Yeah.
Okay, so explain in very short what is API gateway.
Yeah, API gateway is like we can say a single entry point for all client requests in microservices architecture. So it handles routing, authentication, load balancing, logging, rate limiting, and also sometimes the response aggregation. So all these things happens here. So it helps uh, like to hide internal service details from clients and reduces cross-cutting concerns and improves the system maintainability and security. So yeah, so that is what in very short about the API gateway.
So, how do you handle data consistency in microservices?
Yeah, since each microservices manages its own database, so global transactions are avoided and eventual consistency is achieved using the techniques like sagas, event sourcing, or outbox patterns. So services publish and consume domain events to keep data synchronized without a tight coupling. So that ensures the consistency over time. So yeah.
Okay, suppose we deployed new microservices version fails due to missing environment variables. So, what will you do in this case?
Yeah, if a new microservices deployment fails due to missing environment variables, in that case, first of all, we will verify the deployment environment configuration. So we can ensure all required variables are properly defined in the runtime platform, whether it's a Kubernetes, Docker, or CI/CD pipeline, whatever it may be. Then I will cross-check that the variable names match exactly with what's used in the code or configuration files, as even the minor like typos or case differences can cause the issue. Then we can also validate and check like variable injection using the add value or add configuration properties annotation, and we can ensure the default or fallback values are provided where like appropriate or not. And then additionally I inspect the active spring profiles to confirm the correct property file is being loaded. So if the issue still persists across the multiple environments, then we can consider externalizing configuration using Spring Cloud Config Vault. So or configuration like environment management tools like Kubernetes, config maps, and all we can use to ensure the consistent and secure property management across the deployments. So these are steps we can take to check for the new microservices version failure.
Okay, so two microservices, let's say they are communicating via REST and one slows down the another, then how do you handle it?
Yeah, this issue is common in distributed system when one microservices is slow down or failing the service, and that basically that causes the cascading delays. So the solution is to like implement a circuit breaker pattern using the tools like Resilience 4J or Restrix to prevent repeated calls to the failing services. So along with that, we can use retry mechanism for transient failure and fallback logic to provide a default response or cache data when the downstream service is unavailable. So we can also combine this with timeouts or asynchronous communication to isolate slow services and keep the system responsive. So yeah, so this is how we can handle it. Yeah.